This Week in Radio Tech, episode 147, is brought to you by the Telos IQ6 and the new Telos HX6 talk show systems. 6 lines, POTS or ISDN, and 2 advanced Telos hybrids for clear color audio and easy conferencing. On the web at telos-systems.com.
And now, our feature presentation.
TWiRT.
Internet audio streaming is easier than ever, and more people are doing it. So what's the audio processing all about? We explain on this episode of TWiRT.
All right, calm down. He says that to everyone.
This calls for immediate discussion.
What's up, Dad?
All your days are belong to us.
From his palatial office of important business,
or in a choice hotel in a distant land.
This is Kirk Harnack.
Tom Ray and Chris Tarr are joining in to talk about audio streaming, FM translators, and the latest news about the sale of Harris Broadcast Division.
You're dialed in to This Week in Radio Tech.
Hey, it's time for This Week in Radio Tech. I'm Kirk Harnack, your host. I'm really glad you're here. We've got a great show ahead. I'm excited to have 2 co-hosts along with me, each to regale us with stories and let us hear about their knowledge and share what they know about broadcast engineering. Hey, on the show today, we have from New York, from the Hudson Valley of New York, Mr. Tom Ray. Hello, Tom. How you doing?
Oh, wait, share what I know? That'll only take about 30 seconds, Kirk. Hey, I'm doing good. How about yourself?
I'm great. Glad you're with us. All your Christmas shopping done?
Just about there. Got a couple other things. WWW is a wonderful thing.
Yeah. Well, and Tom, tell us just for a second what you're up to nowadays. We all know in the industry that the station that you've been with for years and years, WOR, was sold. It was later revealed it was bought by Clear Channel. So what are you doing nowadays?
Well, I'm still at WOR, and we're still owned by Buckley because there hasn't been a closing and the FCC hasn't approved the sale yet. So I'm still taking care of the transmitter and everything else at OR. So that's about it for now.
And for those who don't know about this, how this works, when you buy a radio station, it's not like buying a gas station. You can't just close when you want to, when the realtor's ready to close and the title's proven to be clear. You have to obtain FCC permission to transfer the license as part of the purchase procedure. And so, in fact, most contracts are written, contingent upon FCC approval of the license transfer. So you have to wait until the FCC approves the license transfer from Buckley Broadcasting to Clear Channel, and then you can have a closing. Something like that?
Exactly like that.
Okay.
So just in wait mode.
All right. Hey, our other co-host from Muckwonago, Wisconsin, it's Chris Tarr. Hey, Chris, how are you, sir?
I am fine, thank you. Glad to be here.
Great. Glad you're along. And you're going to be give us a little taste of what you're going to be telling us about.
Well, one of my many hats that I wear is a contract engineer, and I'm working on installing a transmitter up in northern Wisconsin, translator, and running into some fun issues that we can discuss. I think we've on our way to resolving the issue, but it's an interesting story and kind of how we've been battling it. So I just literally got back maybe an hour ago from up north. I was there, left last night, and spent the night there, did the work this morning, and then came back home. So just got done doing that. I also just got done installing an AM transmitter this past weekend. So I've been busy.
Really? An AM? I didn't realize this weekend's job was an AM transmitter. That's interesting.
Yeah, this past weekend, Nautel AM transmitter.
Okay, cool. Well, we're going to talk about those things coming up. So here's what's coming up on today's show. Got a couple of topical things to discuss briefly. We're going to get into Chris Tarr's stories of engineering daring do. And we've had some requests to talk about audio processing for podcasting or for streaming. And whether, live processing or file-based processing is the way to go, depending on what you're doing. So we're going to talk about that. We're going to try to give you some live demonstrations. It's hard to manipulate the audio itself, but I'm going to show you some of the fundamentals of multiband audio processing and what you want to be doing for processing for streaming. So we're going to try to do that live here on the show. Okay. All right. Well, our show is brought to you by the folks at Telos, my employer. I'm so delighted that they agreed to sponsor the podcast, and we'll hear from Telos a little bit later on. Right now, I want to get to a couple of topical things. There's been a few items in the news here lately. One sad note to pass along. A lot of folks knew of an engineer, an FCC engineer from the field office in Atlanta, Georgia, a guy named Angelo Ditti. Angelo Ditti, a name that you hear once and you just don't forget. Tom and Chris, I'm guessing neither of you ever dealt with Angelo Ditti on a field inspection, right?
Correct.
Right. Well, I engineered for stations that were in the Atlanta FCC office's purview, like in Memphis and in Mississippi. And I'm pretty sure I met Angelo Ditti once on the first inspection. After that, there was another engineer that came by. But everybody in the South, Alabama and Georgia, parts of Mississippi and Tennessee, probably northern Florida, at least, they all knew Angelo Ditti. He passed away at 87 years old, and folks just loved Angelo Ditti. He passed away in Canton, Georgia. He was also an FCC inspector in California earlier in his career, also in Florida and in Georgia. And then he worked to help as an inspector and to help stations with the Alternate Broadcast Inspection Program, ABIP, Alternate Broadcast Inspection Program. That was for the Georgia Association of Broadcasters. Hey, Chris Tarr, I want to ask you about this. Have you had any experience with this Alternate Inspection Program?
Yeah, just got done doing 6 of them.
Oh, wow. Well, give us a quick overview of what that means. I understand that it can be kind of like a get-out-of-jail-free card. Isn't that right?
Well, it is and it's not. What happens is you sign up with your state your state broadcasters association for this alternate inspection, and what it is when you sign up, you have, I believe it's 3 months to have the inspection done, so it gives you some time to prepare. Essentially, when you sign up, the FCC is notified that you've signed up, and it exempts you in the first period, that first 3 months, exempts you from any routine inspection. However, if there's a complaint or something like that, the FCC will come by and they'll inspect. But in terms of routine inspections, you're exempt. Then what happens is somebody who's authorized by the FCC to be an alternate inspector working for the Broadcasters Association will come by and go through a full FCC inspection. The difference is you don't walk away with any violations or fines. What happens is that the inspector will make a note of things that need to be addressed and then give you the results. And you'll either pass with pending a few changes or, any kind of things that you need to fix, or you'll fail. If you fail, you have the opportunity to get re-inspected and to make some changes. Now, if you pass, they notify the FCC that you've passed your alternate inspection and you are exempt from, again, routine inspections for 3 years. So for the next 3 years, you're not going to get the FCC stopping at your door to take a look. However, again, that doesn't exempt you if there are issues or there are complaints about your facility. So it's a great program. I not only did I do it for the intercom stations, I do it for my clients. I know, in fact, I know the inspector pretty well, and he's a great guy. And really, the goal here is compliance. It's not to catch you with anything. In fact, I always I tell people sometimes it's good that they find this stuff because there are so many rules and so many things to remember that oftentimes things go through the cracks. Well, this is a guy who's on your side taking a look and letting you know the problems that are found. And then again, once you fix them, you're done. So there is a fee for it. It's several $100s per station, but it's well worth it. Not only, obviously for the exemption, but also to learn a little bit more about, what you're doing. This guy, in fact, gave me some suggestions for some things that I could do better that, were okay. But, I said, well, my experience, if you do it this way, it's a lot cleaner and that sort of thing. So, yeah, they're fantastic. And I highly recommend anybody out there who's in engineering, take a look at the program and get involved.
Does every state have this kind of program or just states who have gotten together to offer it? Through their maybe
I think it's just states that are involved. I don't think every state's involved. I think it's up to the Broadcasters Association in each state to do it. And Wisconsin's is pretty well known and pretty active. And again, I think I did 6 alone here in the past 6 months, and I've helped a couple other stations successfully pass theirs as well this year.
Cool. Tom, you got any experience with this alternate inspection program in New York?
Oh yeah. Yeah, we had it done. Let's see. I think it was last year we had it done at WOR, and we've done it. Gosh, I've been there 15 years, and I think we've done it. The inspection's good for 3 years, as Chris said, and for at least 12 of those 15 years, we've been under the alternate inspection program. And actually, it was quite funny. Last time we had it done, the day after we had it done, I mean, we passed, not a problem, passed with flying colors. And the day after, I get a call from the FCC. The guy says, I'm out here at your site. I said, well, okay, that's nice. I'm in Manhattan. What can I do for you? He says, well, I'm looking to get in. I says, well, I'm going to have to come over there. I says, do you need to get in now? He says, well, actually, I'm looking at your signage, because you have to identify the tower. The tower, if generally if it's over 200 feet, but there are some other regulations that come into play here. You have to have a registration number for it, and it has to be posted right next to the tower base, or actually on the tower, and preferably on a fence, someplace where there's public access. So, if somebody needs to identify that tower, they can get the number and look it up in the FCC database. So he says, I says, first of all, we passed our alternative state inspection yesterday, and the guy says, oh, well, I guess then I'll go away. But you mind if I look around? I said, knock yourself out. I said, where are you? And at the WR transmitter site, Tower 1, which is our reference tower, sits on a little peninsula. And the access to it is down a railroad right away from New Jersey Transit. Now, I can tell you about New Jersey Transit. They don't like people on their right of way unless they know who you are. And I said to the guy, I says, if you're over near the train tracks, if I were you, I would get the hell out of there. He says, well, why? I said, because if the New Jersey Transit Police, if one of the engineers reports somebody near the tracks, the New Jersey Transit Police will come down, and they are not going to be impressed with your federal badge. Ooh. You're going to be taking a trip to Hoboken and sitting around for a while. He said, okay. He says, so how can I get to those other towers? I'll just walk right to them. I said, not unless you got your swim trunks on, because you're going to end up in the drink. So he left. I never heard back from the guy. And it was great.
What Tom mentions happens. There are stories out there because they give you a certificate, and I've gotten anecdotally stories. In fact, this was from an alternate inspector that the FCC has showed up at a site to do an inspection, and they put the card up. Show the certificate, and the guy says, "Have a nice day," and walks out. So, again, to be very clear, it doesn't exempt you from complaints or anything else. It's simply from routine inspections. But again, it's another set of eyes, and every 3 years you have somebody coming through and saying, "Yep, you're good," or "Nope, you need to work on this." So it's a great tool. The insurance aside, which is obviously nice, and the FCC likes it because it cuts down on things that they have to do. So that's nice. But just being able to get that feedback on your facility is fantastic.
I would agree. Yeah, I realized, I think Terry Bond, when he was on our show a few months ago, he talked about this all
for a long time.
Yeah. Hey, okay, let's move on to another quick subject here. In the news in the last few days has been that Harris has sold its broadcast division. We all, as broadcasters, we think of Harris as all they do is transmitters and audio consoles and such, and well, of course, that's the broadcast division, and that division is but a very, very tiny little bitty part of the Harris Corporation, which does they're a industrial military complex contractor. They do a lot of that kind of stuff. Well, we knew that it's been on the block for sale, and a company, an outfit, a private capital firm called the Gores, Gores, the Gores Group, has purchased Harris. What do we know about that? What do we know about the Gores Group, and what does this mean for Harris? You guys have any speculation?
I got a call from one of the Harris sales guys today who said he thought it was a good thing. Because they will probably just end up being spun off on their own eventually, and they can now concentrate on what they do, which is broadcast. They can make transmitters, they can develop transmitters, they can do the other things they do. They're not just transmitters. They have audio consoles. They do. They have a division called Intraplex, which does T1 interface equipment. Not really high speed, but 1.54 megabit. Interfacing for broadcast groups, that takes the audio and translates it to digital and translates it back at the other end for transport. They make STLs. They make a lot of stuff, and they're a good company, and they've been around a long, long time.
Yeah, I agree. I think Harris, and I think that's the reason that when you get an equity group like that buying something like that, generally it's because they believe they can build it and sell it. And for a long time, Harris Broadcast was kind of hamstrung because they were their smallest division, and they really they were kind of an afterthought to the other stuff that they do. And in fact, there was a lot of brain drain and resource drain for the broadcast division to focus on these other divisions of Harris. So I agree with Tom. I think I think that this has the potential to be a good thing for Harris, and it'll be nice to see Harris as a group, as a transmitter group, get back to their core stuff, which is the broadcast transmitters.
Couple of broadcast-related companies are already part of the Gores group, their holdings. One, a name that we know, and that's Dial Global. They do a lot of networking, network programming. So the Gores owns Dial Global. They also own a company that I've heard of for 15 years now called Elo Touch Solutions. Elo. They make touchscreens, and back years ago when I worked at Scott Studios, we used Elo touchscreens because they were the ones that at that time, in that nascent time of touchscreen technology, Elo was the one that tended to work. I don't know. They own other companies like they have some portion of Siemens, Norman Security, Stock Building Supply, Tiburon, United Road, Alliance Entertainment, a company called Alpheus, Compudyne, Cosmo, and Terrasys. So they own a bunch of these kind of companies currently, and so they'll be adding Harris. Yeah, I think it could be very good for Harris. Let's see. In reacting to this, Broadcast Electronics, competing company, their president and CEO, Joe Rourke, said that the Gores Group is the type of firm that will come in and try to make operational improvements in their new purchase. They'll try to find synergies, reduce costs, and raise cash. That sounds like, of course, it's possible. Some people may get let go in that time, but they'll also, I'm sure, fund it in a way to try to make it turn a good profit. Joe Rourke of BE characterized the $160 million cash portion of the price as being low, but he sees that as an indication of how tough the broadcast manufacturing is at this time. VP of Radio Engineering for Greater Media, Milford Smith, said he's pleased the deal is now done with seemingly well-funded buyer, that being the Gores Group. The expected sale of the division announced after the NAB show left some uncertainty, which has not always been good, in Smitty's opinion, for Harris Broadcast nor for the industry. So it's good that I guess we have some expectation that Harris products won't be abandoned. I didn't really expect that. I mean, they make great products, so you'd think that whether it's Harris or a private equity firm or somebody who would come in and buy up the assets and maybe not the Harris name or whatever is going to keep that technology going because there's a market for it.
Well, in the interim there, Kirk, I think that it may have hurt the Harris a little bit on the transmitter side. I mean, I know personally that I consulted back in the spring for a station, and for 30 some odd years now, it's always been a Harris transmitter for me. And this time I told them go with Nautel. I didn't feel I could recommend the Harris, not knowing if they'd still be around. Yeah.
Well, I'm sure other transmitter manufacturers, took advantage of that doubt that's there. So, well, let's move along. Our next subject we want to talk about is Chris Tarr's subject. Chris, you were involved with 2 engineering projects here in the last few days. What do you want to whale on first here?
Well, the AM transmitter installation is pretty cut and dry. There's not much of a story there. Had a 1,000-watt Nautel transmitter rack mount, and like an hour had it in and on the air. So,
oh gosh,
really not much to talk about there.
I take it this is an existing location, right? That tower is already done. ATU's already there.
Oh yeah, and in fact, the tower actually is on the roof of a building. It's a pretty interesting site. And they had an old, essentially, I got called in on a project. They had a Harris Gates 1 transmitter as their main transmitter, and it had blown a couple of FETs, and they needed me to come by and take a look. So I got ready to do the FETs, and their backup transmitter, which was a whole old Gates BC, I believe it was like a 1C or a 1T, or 1G or 1T, an old Gates transmitter wouldn't come on. Okay, well, I can't work on this if this isn't working. So we sat down and we discussed what was going on and really kind of did the math. And I said, well, here's the deal. This transmitter obviously is the Gates transmitter is old. 50s technology, 60s technology. I said, I could probably make this work. I said, it will take I'm sure close to a day's worth of labor and lots of parts. And even then, I can't guarantee that it will continue to run. So at that point, you're almost a third of a way to just the cost of a brand new transmitter. That's what I recommend. What you should talk to your owners about is, retiring that old Gates transmitter. We'll buy a new one, and then your Gates one, your Harris Gates 1 becomes the backup transmitter, and we replace it with like a Natal or something, and you'll have a brand new main transmitter. So they called me back a couple of days later and said, yeah, let's do it. So that's what we did. We retired the old Gates transmitter, put in a Natal J1000. That's now their main. As soon as I got that on, repaired their Gates 1. That's now which is a solid state transmitter. So not only now that they have a new solid state main, but their backup transmitter is a nice solid state rig as well. So they're pretty well set up. So that was my project on Sunday. We got that knocked out and taken care of. The project I'm working on now is a translator up in Door County, Wisconsin. This is something I've been working on for years. It started out where, without getting too deep into the FCC rules, you can move translators, but you can only make minor moves to them. So if you want to move them anywhere, it takes a long time. So this has been a couple of years in the making.
27 minor moves later, here we are.
No. It wasn't even that far. And at one point I actually considered trying to file a waiver to do it, because it wasn't one of those where I was trying to move it from a small town into a huge city or something. It really was about location. It was the same general area.
Yeah.
So anyway, fast forward through all that work, getting it moved. I found the perfect place for it. Great coverage. Got it there, put it in, installed it, got it all ready to go, and it's co-located with another translator. Turn it on, wiped out the other translator.
Really? So in what way did it wipe it out?
Well, that's what I'm gonna explain. The output of my transmitter is on 93.3. The input of their translator is 92.7. So it was close enough where we would fire up and it would just swamp the front end of the receiver and it would go crazy and you'd hear all this noise. So we need
to stop for a second and explain what a translator does, because not everybody listening or watching knows what that means.
Well,
an FM translator.
An FM translator takes a signal off the air on one frequency and rebroadcasts it at a lower power on a different frequency. And a lot of times people use these for filling in coverage gaps and things like that. Okay. So essentially you have a receiver that listens on one frequency, then rebroadcasts what it hears on another. Okay. So essentially, I was transmitting on 93.3. This other translator was listening on 92.7. So fairly close in frequency. So typically what you would do is you would put in some sort of notch filter on the receiver of the other translator so that we would beat down the 93.3 signal and the 92.7 signal would get into their receiver and all as well. So we put that in there and it was even worse. I mean, instead of just being noisy, the signal just went completely away. Ooh. So I had a friend of mine with me and fortunately he brought his spectrum analyzer. So we measured the signal of this 92.7 that was coming in, and it was microscopic and
weak,
just above the noise. So what we found out was the insertion loss of the filters pretty much just destroyed the signal. It worked. we sat there and we tuned this dual can filter, and we tuned it, and we actually got the 92.7 signal to show up. And we were able to get rid of most of the 93.3 signal. So we got about 95% of the way there. However, there was so little signal that we were concerned that when we had any kind of tropospheric ducting or anything like that, the signal would just get wiped out. So being the good neighbor, we shut down the 93.3 translator. And my next step now is I'm going to order a specialized receive antenna for them that's cut the frequency to 92.7, very directional, like either a log periodic or a Yagi antenna. And what they have right now is a real broadband, just a very broadband, like a 4-element Yagi, and RG8, like cable TV coax coming out of it down to their receiver. Yeah. So I'm thinking that by replacing it with a more specifically tuned antenna and maybe half-inch heliac or half-inch coax, I should be able to get their signal strength into their receiver high enough to overcome the insertion loss of the filter, and therefore we can all live together in perfect harmony. Because we're going to need at least 5 or 6 dB more of signal from their remote transmitter site in order to overcome all of this. So we're figuring that changing out the antenna and the feed line for them will get it there. And again, being the good neighbor and being the guy who moved in, obviously I'm having to buy all this stuff.
Yeah. And that's the way it works in broadcast. If you've got a site where there's where you're an addition to an existing site, you got to pay for anything that needs to be done to make people whole after you move in, right?
Right. And I kind of knew, obviously, when I looked at the frequencies, I knew that this was certainly a possibility. I had hoped that by just using a notch filter that we'd be able to notch out the 93.3 transmit signal enough to make their stuff work. And like I said, we got close. I mean, when we first turned it on, it was horrible. And then we started tweaking on the filter, and we were able to get it dialed in pretty well to the point where when there was no modulation on my end, their signal was nice and clean, and then a little bit of noise remodulated. But we had beaten down their receive signal so much that we just knew that the minute that the weather would get bad, it would just go away. So, I couldn't do that. So I said, well, looking at the receive stuff, it was pretty, because there's nobody else there at the time, so they didn't spend a lot of money on the receive side because they didn't have to. So, using my knowledge, went, okay, well, I think we can get a couple of more dB with, lower loss cable and an antenna that's, tuned to that frequency so that it's very, it hears really well at that 92.7. And I think that'll probably give us enough gain to overcome the losses of the filters and make everybody happy. But again, those are things where, we came in the morning, I met their engineer for the other translator there. And when we got ready to go, we both were thinking this was going to be a slam dunk. We have this really nice filter, and we'd throw that in there, and we'd all go home. And but that's where things like spectrum analyzers are so handy, because there's really no quantifiable way to measure a signal without a piece of equipment like that. I could say, well, it sounds like it's stronger, but I don't know. So as we looked at this filter and it wasn't doing its job, we're trying to figure out what the deal was. So by hooking it up to a spectrum analyzer, we could immediately see that the received signal on 92.7 was very, very weak. And so that really helped with the troubleshooting. And then we could also tune the filter using the spectrum analyzer and watch it, watch us beat away the adjacent signals and peak their signal through the filter. So it was a really interesting experience just to work on in terms of having to use kind of a lot of skills in our toolbox in order to get this to work. But at the end of the day, we were actually a lot farther ahead than we were when I first put the thing in and flipped the switch and completely blasted them out of the water. So we made a lot of progress, just not quite there yet.
Yeah, gotcha. Well, I'm curious about a couple things. First of all, you're definitely going to get better performance with that much bigger and cut to frequency FM antenna. We've done that in American Samoa, where we had to pick up a signal from across the island. It wasn't all that far away, but we had a lot of transmitters there in the area, so that'll help. I'm curious though, do you feel you might have a need to do any filtering of the output of the 93.3 transmitter?
No, I mean, because we also looked at that on a spectrum analyzer, and it's really clean. So that doesn't appear to be the problem. What appears to be the problem is that without any filtering at all on the receive, we were obviously just overloading the front end of that receiver that they had. It's just
I'm sorry, you may have said, what kind of receiver is it?
In Avonics, they do a composite, so it takes the off-air signal and passes it based on everything to the transmitter. So it's not. I mean, it's not the greatest thing in the world, but it's a higher end receiver. So again, once we put the filter on there and tuned it, it actually picked up their signal really well, and we stopped overloading the front end with the filter. But the issue became there was so little signal to begin with that the insertion loss of having the filters in there just made the signal just way too weak and fragile. Yeah. So we're going to leave the filters in and then give it some more gain by using a better antenna and better feed line. And we think that that's the one piece left that will really finish the job and get it done.
even the best receiver in the world, has a hard time, dealing with 2 or 3 dB carrier to noise ratio. I'm curious. My business partner at our radio stations, Larry Fuss, he's had some really good luck because he's put in a couple of these that I haven't been involved in so much. He's had some really good luck with these Fanfare brand receivers, and they've always been, the FM translator guys, the company called Fanfare.
Yeah,
have you had any experience with those?
That's the one I bought for mine.
Okay.
So
okay.
I mean, I actually, if you look at mine, I'll get some pictures. The one I built, I did really kind of Cadillac stuff because I know better. So I actually, my receive antenna is cut to frequency. I am using a half-inch feed line on the receive side. I've got the Fanfare composite receiver. I've got a transmitter that has more than enough power to do the job. Really nice weatherproof case with with ventilation fans and a thermostat, and so I mean it'll work for years. I mean we'll get a lot of good service out of it. But I mean you're dealing with low signals to begin with, and in this case, this 92.7 site, they're trying to receive a Class A from about 30 plus miles away. Oh. So I mean there's not a lot of signal to begin with, and then as I said, since there's no one else on site, they went with what worked, and it really was. It's one of those cheap aluminum 2 or 3 element Yagis with the almost like cable TV RG6 or RG8 coax. So I just imagine the antenna and the feed line alone will, in addition to the filter, I think we're going to be just fine. So
now I'm kind of curious. What if that doesn't work? I think it will, and it'll work well enough. But what if you wanted to make it bulletproof? Is there a plan B or plan C?
Sure. Well, I would have to move it at that point. And at this point, that's fine because I'm still under a construction permit, which means I would just have to file an amended permit and move. And I've got some other places in mind. This is the best place. This is the place that I really would like to be. But if that doesn't work, there are some other suitable sites too that I can just file an amendment to and move it again. So. It'll get done. Either way, we'll get it done.
I don't know the rules on this. Is it possible to? What if you could arrange for that other translator, the one that you're stepping on? What if you could arrange for them to be fed from not off the air? Is that even legal for the kind of translator it is?
You can get waivers to do that, but I don't know that I would go that far. I don't know if it's necessary. I think we're so close that this will do the job. I really do, because if you look at it, it's pretty obvious the antenna's old, the feed line's old. They didn't have to do the kind of care and feeding that I've done to get the thing on the air, and so they didn't. So that was at the time a wise choice because there's no one there. So, but it is up to me since it was working fine before I got there. It's up to me to make it work.
Cool, good deal. Hey, we're going to take a break here and hear from our sponsor at Telos. Chris, thank you for those updates on the AM transmitter, easy install, and the FM translator, which has been more frustrating. I appreciate that. Hey, by the way, you are watching This Week in Radio Tech. This is episode number 147. Yeah, we've been doing this a while and learning a lot and having a good time talking about broadcast engineering. We talk about everything from audio and audio processing, getting good audio into the radio station, transmitting it, processing it for transmission, and even helping folks receive it when that needs to be done. We also talk about audio streaming, since that is becoming part of what an engineer has to do. So that's what the show's about. Let's hear from my employer and the sponsor of the show, Telos. I want to show you a couple of things we've kind of shown you before. This is the new Telos VSET 6. This is the new controller for controlling telephone talk shows, new telephone talk shows from Telos. It's Ethernet based, so it's got an Ethernet jack on it. It's powered over the Ethernet, so it's a PoE, power over Ethernet. If you don't have a PoE switch to plug it into, with every one of these, we ship a little power injector. You can just plug it in the wall and run the Ethernet through. It's a loop through. Run it through the power injector, and you're powering this thing. This thing takes this phone takes about 8 watts of power, and the budget on PoE is about 15.5 watts of power. That's what PoE will do. So this is absolutely gorgeous. It's got a a VGA color screen on it. Sorry, it's not lit up right now. And then 6 line buttons. You can pick the lines up and talk on the handset, or you can punch them onto the air into Hybrid 1 or Hybrid 2, whatever your phone system is letting you do at the time. And it also, of course, dials out and stuff like that. Well, that's the VSET 6. Now I've got a couple of boxes here to share with you. I'm going to save this one for second. Going to show you this one first. This is a 6-line telephone system that Telos has been shipping for a while now. It's kind of interesting. It's called the IQ6. And we originally designed it to be a 6-line phone system to be inexpensive that plugs right into the IQ audio console from Axia. If we go around to the back side of this thing, we see there are 6 holes for POTS lines to plug into. You could also get a card to go in here that lets you plug ISDN lines into it. So it'll take 3 ISDN lines, which gives you 6 phone numbers, or 6 POTS lines. But look at the back. There's no audio jacks on the back. There's no XLR connectors. There's no place to run audio in and out. All there is an Ethernet jack that is qualified to do LiveWire. So this 6-line phone system simply plugs into an Axia audio console, and if you have the controller, the 6-line controller in it, you can start taking phone calls just like that. You configure the audio in and out through the LiveWire. You configure the program on hold. So when you put callers on hold, they hear the program. You configure that through the LiveWire. This box, of course, has a built-in web server, so you can just browse right into it and set it up. You can also do most of the setup that you need right from the front panel. So it's very convenient, easy to use, and it's just a little over $2,000. So it's really pretty cheap for a 6-line phone system. Digital audio in and out. It's just as cool as can be. So if you've already got Axia, that 6-line phone system, the IQ6, will really serve you well. Now, the other one, this is the new thing that we're about to start shipping at Telos. This looks just about like the IQ6. The front panel is exactly the same, except it says HX6 right here. But the OLED screen, the LED input and output meters, they're the same. On the back, you'll find there's 6 phone lines you can plug in, or you can get the ISDN card. But this one, the HX6, has the audio connectors on the back. There you go. You can see XLR connectors. Let's see if I can get this up in the camera range. XLR connectors for program on hold input, for inputs for the mix minus to go to the caller, and then caller outputs right here. Those are all on XLR connectors. There's also a couple connectors for GPIO, so you can see if a call is ringing in on a normal listener line or on a hotline. There's a differentiation there. But there's also an Ethernet jack on this one. And this is how, through Ethernet, this is how both of these phone systems talk to the VSET 6. You can put just one VSET 6 onto one of these. You don't even need an Ethernet switch to do that. You can also put more than one VSET 6 for control. Just give them different IP addresses and point them all toward the HX6 or the IQ6. And just plug them into an ordinary switch. It doesn't have to be LiveWire qualified on the HX6 because you may not be using LiveWire. And you can control the HX6 from several different VSET 6s, or you can control it with the free PC software called X-Screen that comes with that comes with the HX6 and the IQ6. So check them out on the web. They're on the website at telos-systems.com. The 2 new talk show systems, the IQ6, actually it's been around a couple of years, and the HX6, which is brand new, shipping just this month from Telos. Of course, the HX6 costs a little bit more. If you've already got an Axia system, you don't need the HX6, you get the IQ6. Is all that clear? Did I confuse everybody? Let's take any questions from the co-hosts. Tom, are you clear on this? Tom? Is Tom there?
Clear as mud.
Okay. Chris Tarr, you clear on all that? Did you get that?
So you got the one box. The one box just has the Ethernet on it. Then you got the other box. That box has the audio. It goes in and goes out tonight, right?
You got it.
I got it. All right. No questions.
Yeah. All right. You have any questions? Contact your Telos dealer or give us a chat, a call, an email, whatever. We'll help you out. Talk show systems, that's what Telos is really good at. Okay, let's get back to it. Andrew's going to show my screen here, and the screen that you're looking at, I'm remoted into what I call a utility PC at our stations in Mississippi. And this utility PC does a number of things. One thing it does is it's using this cute little program. This would be a good tip of the week here. This auto recorder by Chris Scott. Chris Scott is a broadcast engineer and consultant, and he makes that calibrated AM antenna that folks use for their NRSC measurements, for example. He also makes great little filters, by the way. Chris Tarr. Chris Scott makes these metal boxed receive filters that are tunable. And you probably have ones that are much better. It sound like you get some canister type, but if you need something that's not as good as what you had, and only $100, $150, something like that, Chris Scott will whip you up something that's very nice. Anyway, just to let you know what what this is doing, we have a radio station in American Samoa that, from American Samoa, the satellite AMC-8 that carries so much radio programming on it. Well, it's right overhead. I mean, if you had good enough eyes, you could see the satellite, but the antenna pattern does not include American Samoa, so the signal is just nothing in American Samoa, even though you can see the satellite. Well, that means that in Samoa we can't pick up all the news networks and all the long-form programming and such. So in American Samoa, it's our desire to provide hourly, timely radio news to the people in American Samoa. So we record the news. We're having to be a Fox News affiliate at this station. We record the news in Cleveland, Mississippi, at our station there, where we do obviously have satellite coverage, and we put it on an FTP server, and then our station in Samoa just dials in every hour and downloads the latest news. Now, it's played back, 10, 15 minutes late, but there it is. So anyway, that's what that's all about. And then we also do customized weather forecast from Tom Churchill's service, and that's what the Byte Blaster engine is doing there. It's ingesting the National Weather Service weather wire, basically what we used to know as the weather wire. Okay, well, let's start. What I'm going to do is I'm going to show you what we're doing to do audio processing and encoding for a web stream. And so this is the Omnia AXE program. You might remember, if you're a longtime listener and viewer of This Week in Radio Tech, we gave away a number of Omnia AXE software packages to folks on the show over about a year ago or so. So here I'm running Omnia AXE, and I'm going to use this as a teaching example to talk about audio processing for stream encoding. So Omnia AXE is a program that does both of these. The AX part of it, that's audio processing, 3-band audio processing, and the E part is encoding. So this PC that you're looking at right here, that we're dialed into, this PC is happens to be on an Axia Livewire network. So it's got 2 network cards in it. One network card is connected to the business network and the internet, so that's how we're looking at it right now. And the other network card is connected solely to the Axia Livewire network that exists at my radio station here. And with Omnia AXE, for every license that you have, you can bring in one more audio source. So you can process and encode a number of different streams with Omnia AXE, or at least a number of different programs. So I've just got one license here. So we're the audio source is this one we call WKYX. Actually, it's KXY. I always forget my own call letters. We call this the post EAS feed because my business partner wants to hear EAS over the stream that he listens to. So, okay, fine, we do that. And this is coming in through Axia Wave 01. That's the name of the driver. We could add more if we had the license to do that. We can give it a friendly name and give it a source device here. There's all these different devices that exist in the box, so we could bring all these different programs in if we wanted to. Okay, now back to the main screen here, audio sources, and you can create a new instance. You can create just an audio processing instance that just processes the audio and sends it back out through the Windows sound system. You can make an AAC encoder instance, and you can make an MP3 encoder instance. Now, it turns out that when you make an encoder, it includes the audio processing. So actually, this extra processor I have down here, we don't really need. It's really this one right here, this AAC stream. We get a quick look here at the audio input level and the audio output level for this encoder. And let's see what we can do to go edit a couple things here. We can edit this instant property. So let's take a look here. Okay, this is the streamer. Tell you what, we'll save that for next. Let's look at the audio processing. So I'm bringing this audio in from the LiveWire network. So it comes into the computer through a network card. It gets stripped of the packet headers and such, and it's linear audio at that point inside the Windows computer. And we tell the Omnia AXE program to grab that sound device, that Axia Wave 1, give it a friendly name of WKXY post EAS, and now we have the audio processing. Well, in the audio processing, we have all these different blocks that we can make adjustments with. And the first one would be the input block. So we can set the gain, the input gain on the left and the right channels, so it's fairly consistent for us. I happen to know that at this station, the one and only live announcer and the automation system are pretty consistent on their levels. So I don't mind running this up to -6 dB full scale all the time. If we had a lot of different live jocks and a lot of variability in the level they were running on the board, I would probably run this a bit lower. So, by the way, I guess I should preface by saying, the whole purpose of audio processing, well, one purpose is to make your programming just plain louder, because some people like that. And there is some benefit to that, although there's not much benefit to doing too much of that. The other reason, though, is for encoding on a stream. Well, hey, you want the audio levels to be consistent. You don't want to have people reaching for their computer speakers or their Wi-Fi radio, whatever it may be, and having to turn the level up and down. So we want to give them a reasonably consistent experience with the levels. So that's what the audio processing is there to do. We can do make the levels more consistent. We can give it a bit of a signature sound if we want to, and we can make it louder if we want to. Being loud on a stream, though, not really that important. Being as loud as other streams, probably worthwhile. Anyway, we'll get to the first portion of the audio processor here, and that's the wideband AGC. AGC meaning automatic gain control. I happen to like this control, and that's why I have it cranked all the way up to 6 dB of drive for the wideband AGC. So you say, well, what does this do? Well, any automatic gain control function, I liken it to, there being a little man in there with a volume control. And if the incoming audio gets too loud, he turns it down. And if the incoming audio gets too soft, he turns it back up. Well, that's the metering for this wideband AGC function is done right here under WB, wideband. It's not Warner Brothers, it's wideband. And, we're doing a pretty consistent level here of 12 to 15 dB of gain reduction. The action that a stage is taking is measured or quantified in terms of gain reduction. If the audio stops, this gain reduction will go back up, and that's the equivalent of the little man in there, turning the volume back up. So all the stages ride in some amount of gain reduction. That's a convention for how audio processing is done. There's a couple other features here on this wideband processor that we can fiddle with. One is the gating. We can turn the gating on or off. And gating, for those who need to know, gating is just the idea that, hey, if the audio level coming in drops below some given amount, you know what? We're just not going to try to turn it up if there's nothing there. We're just going to turn up hum and hiss, possibly, if we just crank it up. If the audio just goes away, you know what? We're just going to freeze where we are. We're not going to try to turn up something that's not there. So that's what the gating does. You can turn the gating off like that. And if we were to turn the gating off, if there was a period between the songs here, you would see this wideband AGC gain reduction go up until it finally got to 0. And you may have heard this effect during, when you were a kid and you were listening to a baseball game on the radio. if you're as old as I am, that was before audio processors had the idea of gating in them. And so what happened would be the announcer would say, okay, we have 2 balls and 1 strike, and the pitcher is getting ready to make his windup. And the announcer would be quiet, and the crowd noise would just come up louder and louder and louder. Well, that's because the processors of that day had no gating. And then they would just suck up the audio that was there, which in this case would be the crowd noise at the baseball stadium. Well, gating keeps that suck up of crowd noise or other noise from happening. The other control here is the release time. And by the way, I'm spending a little time describing this on this section because these other sections have the same thing. And so the ideas here are applicable to the rest of the processor. So the release time is, let's say that there's some loud audio coming along and the little man in there is doing a lot of gain reduction. He's got the volume control kind of turned down. Well, when that loud audio goes away and all of a sudden it's soft again, the release time determines how quickly the little man in there goes to turning the volume back up. And this makes a difference. It makes a difference in how natural or unnatural the audio processing sounds. A slow release time is a more natural sound, but it's also not as loud. If you have a fast release time, then the little guy with the volume control is going to be fast to turn the volume back up and let the bring more audio level through. So this release time can change the characteristics of the whole processor and of each individual band when we get into that. There's also a bypass switch here. We can bypass this section altogether if we wanted to, or bypass the processing altogether. Come to think of it. All right, so that's the wideband automatic gain control. The next processing block is there's some bass enhancement that you can do. And there's 2 kinds of bass that are available in this little audio processor. One is deep bass and one is fat bass. Now some of these ideas that I'm giving you here are pretty much universal no matter what brand of audio processor you're playing with. And some of these ideas are, you'll just find in an Omnia audio processor. So Omnia is what we got. I use this for teaching, but I guess some of the concepts here you won't find in other processors, and you might find something else in another processor. The deep bass, that's basically a shelving equalizer that begins at 100 hertz and goes down from there. So if we crank up the deep bass, we're turning up a shelving equalizer, so everything from 100 hertz on down gets turned up. It's not a peaking control, it's a shelving control, which means it's everything from 100 hertz down to 0 gets turned up. Whoops, I just changed it there, didn't I? There we go, it's back. Fat bass is an interesting concept. I'm guessing that Frank Foti invented this, at least for himself. I'm not saying others haven't done it, but the idea here is that fat bass, if you got songs that music or content that has some really deep bass, but a lot of your listeners are using receivers that have speakers that are too small to produce that low bass, thumpy bass, hip hop music, that kind of thing. What if we could create a second harmonic of that deep bass note and add that in as well? So you'd get a bit of the musical. It's musical because it's second harmonic, but you get a bit of a feel for that in smaller speakers. You don't want to use too much of this. The effect starts to get a little odd. But a little bit of fat bass is not a bad thing. So there's a half dB control worth of fat bass added back in. So that's what the fat bass is. Deep bass and fat bass. There is the crossover section, and on this little processor, the Omnia AX, there's no adjustable parameters on the crossover. It just splits the audio into low, medium, and high, and sends those out equally. Now we have 3 AGCs divided up into one that handles lower frequencies, one that handles middle frequencies, and one that handles high frequencies. So let's take a look at the mid AGC. You can see, like I said, the controls here are just like the wideband AGC. Internal parameters are a fair amount different than on the wideband AGC, but the controls that we bring out for you, the user, are pretty simple. There's a drive control, and there's a gating control, and there's a release time control. And so you see these 3 meters over here for low, medium, and high. These gain reduction meters here reflect the settings and the audio that's being impacted by these settings in each of these bands. The low band You can see on the low band we're giving 1 dB of drive level, or of gain to the drive level. And we have a medium release time, and the gating is on. The mid AGC, we have apparently 0.9 dB of extra drive. Same thing, release time, medium, and gate is on. And then in the high AGC, well, it's set up just the same way, 0.9 dB and medium and on. Now, that looks a bit simplistic, like, well, you've got all three bands behaving the same way. Well, no, not really. Certainly Omnia, and I would imagine some other processors as well, are pretty sophisticated inside. And again, we just bring out the controls that matter the most to you. There's a lot of other things going on behind the scenes, like this release time. That's not a fixed time. That's a program-dependent release time in each of the three bands, and for the wide band as well. And I'm sure other processors do the same thing. But for this processor, Omnia AX, we just brought out the things that help keep it simple. And then finally, we have the mix back. This is how we mix the low, medium, and high audio processor outputs back together. So if you think about this, when we adjust processing here, we're adjusting the density of each of these bands. If we were to go to the high band, for example, and crank up the drive, we're feeding more audio into the little man with a volume control. And if we give him a fast release time, he's going to be pretty hot and heavy on that control, always trying to provide a consistent output level from the high band section here. Similar for mid and low, if you want to look at it that way. The mix control, you're mixing three bands of audio, low, medium, and high, and you're mixing them. They've already been processed at this point. So you're mixing together fairly consistent levels already, or levels that are already fairly consistent. So if you do too much here, especially on the plus side, you're really mixing in some dense audio, assuming you've done some dense processing in the three band control just before it. So we call that the mix, or I call it mix back. We're mixing back these three bands. And now we'll go to the final limiter. Simple control, just one drive control for how hard are we going to hit or feed the final limiter. Now, the final limiter in this processor, and really in any processor that is intended to process audio for encoding, for any bit rate reduced system, like MP3 or AAC, and doesn't matter whether it's a file that's going to be made, or whether it's live streaming, or whether it's HD radio. We're processing for not for AM, not for FM here, but for a bitrate reduction process. So we can't just use a hard limiter. We can't use a simple limiter. We need to use a design that's called a look-ahead limiter. And that way we're not doing clipping. We definitely don't want to do any clipping, because a lot of harmonics are created. And that's actually okay for AM and FM because of the way the transmitters and the modulators work. But we really can't do that for a bit rate reduction process like a psychoacoustic encoder. So the final limiter is a look-ahead limiter, and there's another thing that we as designers worry about. A simple textbook look-ahead limiter absolutely positively will create intermodulation distortion. It's a function. It's kind of part of what it has to do look-ahead limiting. And so you want to design a look-ahead limiter that mitigates the intermodulation distortion, the intermod distortion. And I can't speak for other companies. I would imagine some of them have figured out some ways to do that. Certainly the Omnia processor does that very well. It's got a really good mitigation process to predict and mitigate intermodulation distortion that's going to happen. All right, and so that's the final limiter. By the way, a lot of your actual loudness comes from that final limiter, but you do too much of it, and it does get fatiguing. So you don't want to do too much final limiting. You can see my final limiter meters here are, and by the way, the music going through this right now, this is some country music. It's Kicks 92.1. This is our station in Cleveland, Mississippi. You can find that on the internet and listen to the live stream. I think the live stream is probably 56 kilobit per second HEAAC v2. We'll look at that in a minute. So anyway, the final limiters are doing anywhere from 1 to 2 to 3, sometimes up to 4 dB of limiting. And that's probably a pretty, there's 5 dB right there, pretty safe amount to be doing. You can save presets in here or not. There's a whole preset manager available. It comes with, the processor comes with these presets already there, and you can add to it, copy, rename, all that kind of stuff. All right, so that was the audio processing. Now let's look at what's happening with the audio encoding. So we'll go to the encoder section here. Oh, okay. And we've given it a name, Kix9 2.1, the audio source that it was coming from, the preset that's being applied to it. And now here's where we're specifying the format of the encoding. So, you know, any software that does encoding is going to have something like this. We have some choices here. We can encode in plain AAC. It's actually probably AAC low complexity. Most of the time when you see an encoder with an option to encode AAC, it's probably actually AAC low complexity. It just requires a lower complexity decoder to decode it. There's also high efficiency AAC, and then there's version 2 of high efficiency AAC. There's a version of AAC that is called error resilient. I honestly don't know much about this. There's AAC that's contained in an MPEG-2 packaging stream or container, and a HEAC in an MPEG-2 container. These are here, I believe, for compatibility with some satellite networks, so that you can use Omnia AXE. Whoops, I didn't actually mean to do that. I won't save it. I'll put it back there. With some of the encoders, you have a choice between stereo or mono. So if we choose AAC, then we can choose stereo or mono. I was using HEAC V2, which is by definition always going to be stereo. And then you can choose the bit rate that you're encoding at. And then there is a stream type. If you don't know what to use, the default for most applications would be ADTS. But if you're sending the stream to a content distribution network, then you would ask them, hey, raw, ADIF, ADTS, or ADTS with cyclical redundancy check. Ooh, that's a mouthful. All right, so there you go. And here's the stream. It's a shoutcast style stream. And let's see, we can go edit that stream. So that's where we set up the encoding. And then see, there's really two processes to streaming here. Oh, actually, there's several, but here there's two. We encode the stream, and then we got to do some things about where are we going to send the stream. And so we give it a friendly stream name. It turns out the shoutcast server that we're using is contained within the same computer. So that's why the address for the shoutcast server is, the self address 127.0.0.1. The shoutcast stream name. Right now we have no metadata on this stream. I need to get Chris Tarr to help me do that. There's the server password. Gee, don't use that against me, okay? And then the genre, country. The shoutcast stream is public, and it's in shoutcast V version 1. There's also a version 2 mode. And there you go. That's how you do that. I don't need to save that encoder. I just might mess it up. And then let's see what else. Let's see, any options here? Oh, okay. Yeah, there's options for Omnia AXE, like the admin password, various different ports that you can do. So there you go with the different options. All right. I hope I've provided some degree of explanation about audio processing. Hey, let me bring Chris and Tom back in if I haven't put them to sleep yet. Chris, Tom, both of you guys have done audio processing for streaming. Why don't you take a minute and describe your own experiences and what you've found while I get kind of reset with Andrew here. Chris, why don't you take it first and talk to us about your own experience with processing for streaming and compared to what I showed.
Sure. Well, it's I actually use now my current position. I use a Telos product called the ProStream, which has almost the same kind of structure as you were just showing on the computer there. It's just a hardware version of that. However, I also have used, and there's a couple stations that I do some work for that use outbound or outboard processing with a simple streaming encoder. So you can really, you can buy a product such as the Omnia product where it's all built in. You can do it separately. There's even free things. There's one that and the name just escaped me. Audio processor for free one that works. I think is like a Winamp plugin. That works exceptionally well. So, a couple of things you want to remember, though, when you're encoding for streaming processing is that the way that the stream encoding works and the way that the data reduction for encoding works is it removes bits that supposedly you can't hear. So you need to have some dynamic range in the audio for the encoding to work efficiently. So be sure to not do the brick wall, everything to 11 type of processing. And then the other thing is a good trick is you can roll off the high end. You can put it through a filter and reduce some of the bandwidth and actually have a better sounding product coming out of the other end of the stream. So you can actually tailor processing for streaming to eliminate some of the swishing noises and some of the lower bitrate codec artifacts as well. So there's some techniques to do that as well. But bottom line is you can either do all in one with the software and the encoding, or you can do outbound or a combination of both. And I've done all three.
Am I back on? I think I am. That sounds right. Hey, Chris, can you? The one part of all this that I'm just really still lacking on is metadata, and that's probably a whole show unto itself. But can you tell me just a sec about metadata and getting that into a system, and how you get it out of wherever it's coming from?
Well, most encoders now will actually take metadata from your automation system and inject it. So essentially, all you need, and it can be as simple as, for example, Sam Broadcaster, and I know a lot of internet radio stations use Sam Broadcaster, will write a text or an XML file every time it changes a song. And the encoder can pick up that file, can read the data in that file, and multiplex it with the audio that's being encoded in real time. So generally, it's a separate process, but most encoders now have the capability of reading a text or an XML file and taking the metadata off of that. It just needs to know from whatever your playback system is what it is that it's playing. And again, going back to most playback systems now, create some sort of XML or text file every time that there's an event that these encoders can read and inject into their audio.
So I know that the ProStream, and you know this too, in Omnia AXE, that has the notion of a parsing filter. Is that what plucks out the stuff that you actually want to show up as metadata?
Yeah, and there's several ways to do that, because obviously a lot of times you don't want, if you're playing commercials, for example, you don't want that as metadata. You just want a generic message. So what these parsing filters will do will say, okay, if the metadata contains the word music, pass it through. If the metadata contains the word commercial, instead play this. So, or instead show this text. So what it does is the filters, you set up the filters to read what that XML or those text files have and understand from there what data to pull out of that and forward on. So, for example, the metadata coming from an automation system generally will have things like runtime, cart numbers, categories, and you don't want all of that showing up on your stream. So what these parsing filters do is they look at that and simply parse and pull out the information that's relevant and add it to the stream.
Gotcha. All right. Hey, Tom, did we put you to sleep yet?
Oh, sorry. Yes.
Funny. So at WOR, what did you guys do in terms of streaming, and what did you have to learn? Or what can you add to what we've been saying so far about what you learned about streaming?
Well, one of the things I've learned, and actually a lot of people make this mistake if they decide to, they're going to stream. They say, I got this processor sitting on the shelf. I'm just going to use that. And the streaming processors have breakpoints for processing that work with the encoder rather than against the encoder. In addition, I noticed before you said limiting. And there's a big difference between limiting and what we do on the air, which is clipping. What happens in your typical encoder is that its job is to look at the audio and to take out stuff that's not necessary. Well, if you start clipping the audio, what will happen is that it starts generating harmonics, because that's what a clipper does. The encoder doesn't know that these are things that, really should stay in. And sometimes we'll remove the wrong item when you're sitting there with a bunch of harmonics generated, and you get what's called grunge or trash coming out of that thing, and it escalates quickly. So you want to use a processor that has a limiter, a look-ahead limiter, and not a clipper that like you would find on a normal on-air processor. Additionally, you're talking about metadata before. I've used before. I had a stream going here for a friend for a while, and excuse me, I wanted to run it on a more professionally based system, and I found one that's Linux based that is free, except for the support, which is fine. And I needed to encode it, but I couldn't find an appropriate encoder for the service he wanted to use. So what I ended up doing was I ended up building a Windows machine and buying a Windows-based encoder and running a virtual machine with the Linux machine in it. So I was running Linux under Windows. And now I had this interesting problem. I had to get the metadata from point A to point B. I found a real cool freeware program. It's called Hercules. And it takes in whatever the automation system wants to give you. You tell it, basically it's a parsing filter. You tell it, when you see it like this, take these parts, make it like that, and stick it into the encoder. Worked like a champ. And it just worked on IP. I assigned the virtual machine a separate IP as opposed to the Windows machine. I said, when you see it from here, spit it out and put it over here. Worked like a champ. It was great. Right now at OR, we're running actually it's an Optimod internal program. We have an Optimod audio card in there, and we're running Optimod processing on the audio stream. And Chris is right. Also, you don't want to take it and just turn it up to 11 or even try to go to 12, because it'll grunge up and the encoder won't do its job properly, and it'll start sounding really funky. So you want to have a little bit of dynamic range in there. You'd be surprised how loud it can be.
Yeah. Well, guys, we're going to have to draw it to a close here. We've been on for a while talking about several subjects, and we spent the last, about almost 40 minutes on audio processing for streaming. So I appreciate the comments and notes that you guys have added. Hope I gave a decent tutorial. Before we go, Chris, Tarr, any last-minute comment about audio processing for streaming you want to toss in here?
There's I've heard a lot of really good, and I've heard a lot of really bad out there. So be one of the good ones. And remember, less is more.
That's true. Tom, you just gave your opinion. Any last minute thing you want to add in there about, if I'm new to streaming, what I really want to be careful of? Anything we didn't mention? Probably not, Tom.
Let's try it now with the microphone on. That works better. I thought I hit the on button. No, what I was going to say is, or what I was saying, if you're new to streaming, find a program that you think will work for you, install it, and before you make the thing live, play with it a little bit in the house. Because most of these streamers, you can take a computer across the room and take Windows Media Player, for example, and connect to that streaming computer direct and hear what it's going to sound like on the other end, and play with it. Spend a couple days, see what it does. And Chris is right. Less is more. You don't want to overdo it, and you can make that stream sound really good at surprisingly low bit rates. So just take your time
with the right codec.
Correct.
The right codec.
Yeah. And there are a lot to choose, and it all depends on what you're going for, but. I'm not going to say use anyone in particular, but there's a couple I tend to like, and there's a lot I stay away from.
I'm still liking this HEAAC V2, for entertainment purposes. Now, if you want to listen to a symphony, maybe it's not the best, but if you've got a Wi-Fi radio, if you're listening at work, even if you're driving down the road in the car, man, I have heard some really good sounding streams using HEAAC V2, and I'm going to keep pushing on that, because at low bit rates like 56 kilobits, 48 kilobits, it is amazingly good. Perfect? No, but pretty pleasing to the ear if you're not being just super persnickety. It's good entertainment value. Hey, we got to draw to a close. Thanks a lot for being with us. You've been watching episode 147 of This Week in Radio Tech. Our show's been brought to you by Telos Systems, maker of two very cool low-cost multi-line phone systems, the IQ6 for use with Axia systems, and the HX6 for use with non-Axia systems. They're both 6-line POTS or ISDN codecs, and both of them are controlled by this cool-looking thing here, the VSET 6 that just plugs right into your Ethernet network. All right, thanks to Andrew Zarian for producing the show. We're going to have some great shows coming up with who did I mention earlier? Some guys from Nautel about the differential GPS. And who's the meter guy whose name is around the tip of my tongue?
Mike Durow.
Mike Durow.
Oh, Durow. Yes, Durow. Yes. And he's going to give us, he's going to regale us with some stories about audio processing and selling the first, multiband processors out of the trunk of his car. And so I'm excited to have Mike Durow on sometime in the next 2 or 3, 4 weeks. We'll get him on the show. All right, guys. You guys take care. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.
That's all the bandwidth we can pill for this week. Another TWiRT has propagated, and all the transmitters and audio equipment live happily ever after, thanks to the handsome engineer and his kind, benevolent care. We'll be back next week.
Lord willing and the creek don't rise.
This Week in Radio Tech. Subscribe to iTunes and you'll never miss a show. Search for This Week in Radio Tech in the iTunes Store. Soliciting is strictly encouraged. If you like today's show, tell a friend. If you didn't like it, we were never here. Kirk Harnack's wardrobe provided by the Salvation Army and the Red Cross Disaster Relief Services. Hair and makeup provided by Penelope Garcia Hernandez Weinberg.
He's unique, wouldn't you say?
I just want to get it over with.
This ends this transmission. Tango, Whiskey, India, Romeo, Tango. Signing off. Okay.